Okay, people. Today we are going to discuss about the subtopics parametric form in circles. What is that parametric form? Say, if you take if you take a circle whose center is either origin or any other one. Say, suppose if you take that a circle whose center is origin, now it will be in this form. Say, what is that equation of the circle whose center is that origin and radius is that r units? That will be x square plus y square. X square plus y square is equals to r square. This one is that equation of the circle whose center is origin and radius is that r. Radius is that r. Now let it be you take this point as that P is equals to x comma y. Now you draw the perpendicular from P to the x-axis. From P to the x-axis. This one is that Q. Now you know that origin means its coordinates are 0, 0. And let that OP makes an angle with x-axis is theta. Is theta. So now is theta. Here this one is that theta. Okay. Now if P point coordinates are x comma y, this length will be that y and this length will be x. Now very clearly the triangle OPQ is a right angle triangle. Is a right angled triangle. So in a right angled triangle, so here from the diagram PQ is represented opposite side. PQ is at opposite side. And OQ is represented adjacent side. OQ is that adjacent side. And OP is represents hypotenuse. OP represents hypotenuse. So hypotenuse. So here in this one, in that lower classes, to find that any side, we will use the trigonometric ratios. So now first you take that, what is that cos theta value? Cos ratio, you know that adjacent by hypotenuse. So adjacent means OQ. Adjacent is OQ. Hypotenuse is OP. What is the length of OQ? OQ length is that X. Okay, OP length is that R. So now from this one you can write that, X is equals to R into cos theta, right? And next sin theta is equals to, what is that ratio? Sin theta is equals to opposite side. That will be PQ whole divided by hypotenuse is that OP. That is equals to Y by R. Now from this one you can write that Y is equals to r into sine theta. Y is equals to r into sine theta. Y is equals to r into sine theta. Right? So therefore, here x is equals to, here x is equals to r cos theta, comma, y is equals to r sin theta, or sin theta. These are called parametric equations. These are parametric equations. See here, parametric equations. Now suppose x and y values, if you replace in this point p is equals to x comma y, then we called as parametric point. So what is that a parametric point? Parametric point. Parametric point will be, that is that p is equals to r cos theta, comma, r sin theta. This one is that r cos theta, comma, r sin theta. Now here you can observe that, so parametric equations, if you know that, you can write that parametric point. So now parametric point will be denoted by theta. So what is that theta? Theta value should be always lies between 0 to 360, that is that 2 pi. Suppose if you take that center is a h comma k, center is a h comma k. If you take the center is h comma k and the radius is that r, radius r. So then what will be that a parametric form? Simple. Here you know that one concept is there. What is that concept? When origin is shifted to any another point, the new coordinates will be capital X is equals to small x minus h, comma, small capital Y is equals to small y minus k. So here this one. Now in this above parametric equations, if you replace x with x minus h and y with y minus k, you will be get x minus h is equals to r into cos theta. Okay, from this you can write that x is equals to h plus r into cos theta, and similarly y minus k is equals to r into sin theta. From this one you can write that y is equals to k plus r into sin theta. These two are that parametric equations. So when will you apply these two? If center is a h comma k and the radius is that r units, you can use that parametric equation. The formula will be x is equals to h plus r cos theta, y is equals to k plus r sin theta. And what will be that parametric point? Parametric point will be x comma y is equals to, this one will be h plus r cos theta, comma, k plus r sin theta. This one is k plus r sine theta. This one also will be denoted by theta. This is also denoted by theta. Now, the above this parametric point, So when will you apply? When we know the center and radius. So what is that circle different forms? That will be nothing but one is the general form. That will be x minus a whole square plus y minus b whole square is equals to r square. So this is that one form. In this one, what are the parametric equations? Parametric equations will be x is equals to a plus r cos theta, comma y is equals to b plus r sine theta, If you know the parametric equations, obviously you can write the parametric point also. And next, what is that another form? That is the standard form. X square plus y square plus 2 into gx plus 2 into fy plus c is equals to 0. Now what is the center? Center is that minus g comma minus f, and radius is nothing but r. This value will be found by using this formula root of g square plus f square minus c. So whatever you get the formula, whatever you get that value by using this formula, this is that r value. Now in this above formula, you replace a and b with a minus g comma minus f. So x is equals to what is that? Minus g plus r into cos theta, and y is equals to minus f plus r into sine theta. So this one is that parametric equations of the circle x square plus y square plus 2gx plus 2fy plus c is equals to 0. Now, if you know the parametric equations, you can write the parametric point also. Now we will see that one example by taking the circle equation. See, if you take that circle equation will be x minus 2 whole square plus y minus 1 whole square is equals to some 4 is given. Then what is that center? Center is equals to 2 comma 1. And what is that radius? R is equals to 2. Now parametric equations will be x is equals to, the formula is that what? That will be h plus r into cos theta. Okay, and y is equals to k plus r into sine theta. So this is that formula. You know where theta will be lies between 0 to 2 pi. 0 to 2 pi. Now you substitute center is that h comma k, and radius is equals to 2. So that implies x is equals to, this one is 2 plus 2 into cos theta. Okay, y is equals to 1 plus 2 into sine theta. This one is that parametric, this one is the parametric equations. If you know the parametric equations, if you write that x value as the x coordinate and y value as the y coordinate, that is that x comma y. X comma y is that what? Parametric point. This is the parametric point. So like this you can find either parametric point or parametric equations you can find by using these concepts. Okay, so next, like similarly, if you take one more example, x square plus y square minus plus 6 into x minus 10 into y plus 2 is equals to 0. Now, how can we find a center and a radius? Now, center means that is this is called the standard form. Okay, in standard form, center is nothing but what? Minus a g comma minus f. That means here you can write that minus 2g by this one you can write the 2 and minus 2f by 2 you can write. So what is that 2g and 2f in this one? 2g is that x coefficient, 2g is that x coefficient and 2f is that y coefficient. By substitute that x and y coefficient, you can get that value is that minus 3 comma 5. This one is that center. And next, what is that radius? R is equals to root of g square plus f square, g square plus f square minus c. Now, you know that the g value, f value. So here, if you write that g value, minus g is equals to minus 3. So g square is equals to 9 and minus f is equals to 5. That minus f whole square is 25 and c is equals to, that is the constant in the circle, minus 2. This value will be equals to 25 plus 9, that is that 34. 34 minus 2 is that 32, square root of 32. So after you know that center, and radius, how to find the either parametric equation and a parametric point very clearly we discussed in the above example. Thank you for watching this video. Please all of you subscribe my channel.